Hello everyone, welcome to this video. In this video, we are going to discuss about the AC current and DC current. The previous video, we already discussed about what is voltage and what is current. Okay, so in this video, you are going to be learn about what are the types of current, that is the AC and DC current. So this is going to be the simple to understand what is mean by AC and what is mean by DC current. Okay, so we will start to learn this. Okay, so first of all, you are going to be commonly learn about what is electricity. So what is electricity? How the electricity is actually forming. So because of the electrons is going to be moved, right? So we know that it already. So whenever, so you just take any of the conductor, any of the material, it just having the atoms. So completely just having the atoms, right? So depends on the material, depends on the materials, the electrons movement will be there. So every atom which has contain protons, neutrons, and electrons. Okay. So always the free electrons is only get started to flow. Okay, the free electrons will be started to flow, and that will be producing the electricity. Okay, so that is called as current. Okay, so you can easily understand that move electrons will started to move from one place to another, and so that will be started to creating the electricity. Okay, and here this is the common electricity, the movement of charges which is creating the electricity. But here there is a two different things. So one is the DC current and another one is the AC current. That means, so DC means it is called as a direct current and AC means it is called as an alternative current. So what is the difference between these two is this DC current. Okay, so we will discuss about what is this DC current is. Most of the electrical appliances, I'm not going to be tell all the electrical appliances which is only taken the DC current. So if you take your example, you are going to be take your example of your home. So most of the electrical appliances, some of the electrical appliances which requires the DC current. Okay, your TV, some of your mobile phone chargers, so some kind of devices which requires a DC currents. At the same time, some of the devices, okay, so your bulb and some of the devices like your fan, and it will be taking the alternative current. So why it is actually taking the alternative current? Why it's actually taking a DC current? And before that, what is the difference between DC and AC? Okay, so here we will discuss this concept. Okay, yeah, main important thing is in this DC current, the voltage is unchanging. Okay, so it will be constant. Okay, so at the time, the current flow is also going to be same. Okay, if the voltage is not getting fluctuated, so if the voltage is not changing, it will be constant. You can also get the same amount of current in the same direction. Okay, so we will clearly discuss about this one. Okay, first of all, DC current. Okay, DC current, the electrical current which is flow through the only one direction. At the time, the voltage remain constant. Okay, so you always think about the thing. So DC current means it is the current, the charges will be flows through the only one direction. Okay, if you just consider this is the electrons will be started to move through this only one direction, the conventional current will be started to flow. Okay, so the current will be completely through this one direction. Okay, because you have been applied, the voltages remain constant. Okay, so this is called as a DC current, and you can able to tell the voltage is always constant. Some of the slight variation might be happens. So due to this real time applications, and how we can able to see the DC circuit theory is, so always the DC current, whenever you're going to be think about the DC current, it's completely work based on your Ohm's law. Okay, so Ohm's law, we know that it is having the ohmic application, ohmic one. Okay, so all those current, okay, you're going to be keep it on the mind. All the current will be started to flow from positive to negative. If it is a negative to positive means, so the electrons will be flow through this direction, and the conventional current will be started to flow towards this direction. So this is how this DC circuit will be flows. Okay, and this will be the single one directional current. Okay, it will be take the path, multiple path will be go. Okay, but the direction of the current is unidirection. Okay, so it will be flows towards this or this, but you can't able, it is not going to be change. The voltage and current is not going to be changed with respect to time, so you can able to see it is same. So most of the time, if someone asks to be draw the DC circuit, we will draw like this because it is voltage is remains same. Okay, if you're going to be calculating with expected time, the voltage is still same. It is constant. Okay, so this is your thing, and it's unlike AC. Okay, we will discuss about what is AC. So DC means it is not going to be changed with respect to time, so it is remains constant, same. Okay, so if you want to be increasing the voltage, okay, if you want to be increasing the voltage, so current is also get increased, but both are simultaneously. Okay, like your ohmic application. So if I am going to be increasing the voltage, the current is also get increased. That in DC current, right? So at the time, if it is a 5 volt, okay, and the current you're going to be calculated, okay, if you're going to be increasing the current, so if you're going to be increasing the voltage, the current is also get increased. If you want to be increasing the voltage, the current is also get increased. Okay, so both are going to be relativity. So that's why it is going to be taking the Ohm's law. Okay, and it is going to be slightly get vary. Sometimes it is going to be vary. Okay, the symbol is always going to be representing symbol with positive and negative sign indicating the direction of the polarity. Okay, so how actually it is going to be moving. Okay, so and next one, what are the sources which is going to be creating this DC current, direct current? Okay, so first of all, batteries and power supply, solar cells. So these are the things which is going to be helps you to producing the direct current. So if you're going to be using on positive and negative, at the time you can easily move the electrons, right? So if we need some potential difference between the two end of the terminal. Okay. So one is that is the voltage. Okay. When you started to give potential difference between the two end of the node, okay, at the time, the electrons will be started to move. Okay, it will be started to move because it is a negative side. So it will be started to ripple each other. At the time, the electrons will be started to move towards the positive direction. So when the electrons will be started to hitting this positive direction, more amount of electrons will be started to move, started to hit this positive charges. At the time, the electricity will be started to created. Okay, that will be towards this direction. Okay, so this is the logic we can able to see this. So only if you require if you want to be creating the DC circuit, so through that batteries, positive and negative polarity, whatever it is having the positive and negative polarities, we can easily create this DC circuit and power supplies like solar cells. So these are the things which helps to creating the DC circuit. Okay. At the same time, for example, you can, if you want to be creating the 5 volt and 9 volts, so depends on that, you're going to be give the voltage value. A current will be producing. And voltage symbol. What are the voltage symbol we can able to give it is? So this is the these are the symbols. So you can give this is a single cell. Okay, this is a multiple cell, positive and negative, positive and negative. So this is a common DC voltage source. Okay, if you want to be give the DC, these are all the things which is called as in cells, which represent positive and negative. Okay, and this is called as a voltage source. Okay, if you want to be give the somewhat the high amount of voltage, so we are going to be mentioned as an volt. Okay, and this is called as an AC source. Okay, because there is no positive and negative, you can able to see it here because it is continuously going to be changed. So in DC circuit, we can easily predict it. Always the current will be flows from positive to negative. This is the constant thing going to not going to be changed. But if you're going to be taking the AC current, it is continuously going to be changed. So that's what they didn't mention any positive and negative. Okay, both an AC and DC, both DC. Okay, your current and voltage are going to be produced by the power supply, batteries, and dynamos and solar cells. Okay, so using this concept, you can easily creating your uh, DC current. Okay, so you can able to see this concept DC voltage or current as fixed magnitude and amplitude. Okay, so the direction which is already fixed. So if you want to be give the 12 volt, okay, if you want to be give the 12 volt of voltage, for example, you just take voltage. Okay, so it is going to be fixed. If you are given the 12 volt, you can't able to be change the value. Okay, for example, if you just taking one a microcontroller, so microcontroller it is completely the DC, okay, direct current. Okay, if you can able to give only the 5 volt means if your microcontroller which is having a 5 volt or 3.3 volt means you can only give the 5 volt to your any of the peripheral. Okay, so if you are having a 3.3 volt, you can only give the 3.3 volt. Can't able to reduce it directly from the microcontroller. If you want to be reduce the value, you can use the resistor here to dropping some voltage. Okay, and then you can apply to the LED. Okay, it's not be like your alternative current, so the value will be fixed. if you are having a 3.3, or you can able to reducing by using this resistor to dropping the voltage and current. Okay, so that is the thing they have been mentioned here. And next one is DC circuit theory for resistor symbol. Okay, so what are the resistor symbol? We can use it for this DC. So uh, this is the fixed resistor. This is also called as a fixed resistor. So this one, which is called as a potentiometer, if you want to be. So these two, we can't able to change the value. If you are using this resistance means 100 ohm means you can't able to change it. Okay. So these two will be the fixed one. And this is called as a potentiometer. Okay. Potentiometer means you can able to change the value. Okay. Uh, I already explained about the potentiometer, right? So if whenever you are just turning towards this high voltage, the voltage value, the resistance value is reduced. Okay, voltage increases, resistor value decreases. So when you're going to be reducing the value, the resistance value automatically increase. So depends on that, you can able to getting the datas and all. Okay, so LDR is also the same kind of thing. So rheostat. So these three are can able to changing the resistance and the current, and these one is going to be happen based on your light. Okay, so the resistivity can able to happen based on your voltage and current and optical and temperature. So you can able to do all those things by using this fixed and these kind of resistors. Okay, and what are the characteristics of this one? So you can easily understand. So polarity. So when you are just taking this DC current, this polarity is already fixed. It is positive and negative. The charges will be flows to this direction, and current will be flow through this direction. That is the DC current. And you can easily store the charges. While you're going to be taking the DC current, okay, if you are giving a 5 volt, okay, so the current will be started to flow. That current, if you want to be stored into the any component, you can easily store the charges into the capacitor or any solar cell. So these kind of the battery. So here you can easily store the charges. The DC current can easily capable to storing the charges. Okay, and you can directly apply the electronic appliances, some of the LED microcontrollers, motors, because these are the appliances which requires the DC current. Okay, because your LED, okay, your microcontroller will works at 5 volt. LED will works at 2.2 volt. So these are the fixed. DC is already fixed uh, current. Okay, you can't able to change it. It will be fixed. Okay, so it is not going to be varying continuously. It is not going to be varying. So at the time, the fixed kind of voltage, you just simply apply this DC current. Okay, most of the appliances I already told that it is going to be using the fixed current. If you want to be converting the voltage, you just use the DC-DC converter or buck-boost converter, which helps to converting the voltage. Okay. At the same time, current and voltage graph is always straight. So that's in we studied the Ohm's law, right? So it will be in the straight graph. Okay, so it is not going to be changing. So this is your voltage and current graph. So it will be looks like this. So whenever you are going to be using the fixed resistor, whenever the voltage is getting increased, at the same time the current is also get increased. It is linear. Okay, linear circuit fixed resistance. If you increasing the voltage, the current is also going to be get increased. If you're going to be decreasing the voltage, the current is also get decreased. So this is how the DC circuit will be completely get works. Okay. So this is completely the linear concept. Okay. Sometimes it's also going to be works in the non-linear condition also, non-linear value. Then so that when you're going to be keep on changing the resistance value, the value will be non-linear. Okay. And the next thing we will discuss about the concept called as an yeah. So it is very important thing as it doesn't contain any frequency. Okay. So when you're going to be calculating the frequency, okay, so your signal, okay, your current, or in that whenever it just changing continuously, okay, whenever you're just calculating your voltage or current with respect to time. Okay, for example, you want to be calculating your voltage with respect to time. Okay, if your voltage is continuously changing, okay, your voltage is continuously changing with respect to time. For example, this is your voltage value. For example, okay, here you can simply see this one with respect to time. Okay, for 0.1 second, what is the voltage? For example, it is in the uh, zero point 0.1 volt. Okay, it is in the zero point 0.1 volt. Okay, and next is a scenario for a 0.2 second. Okay, 0.2 second. What is the voltage value? It is 0.2 volt. Okay, and what is the 0.3 second? It is having the 0.3 volt. Okay, and what about this 0 point, I mean 0.4 second? So when you're going to be calculating this, you can simply understand your, with respect to time, your voltage is continuously changing. This is called as a frequency. Here only you're going to be calculating the frequency, okay? Because your signal or voltage or current is keep on changing. Okay, whenever it just continuously changing, your frequency you're going to be calculating. Okay. So what is frequency? So for per second, so how much? So your signal, how it is actually going to be changing with respect to time. Okay. So when it is keep on changing, so you're going to be calculating the frequency. Okay. And this scenario, just take it for the DC circuit. You just take your DC circuit. This is time. You're going to be calculating the voltage. So this is your voltage. I already told the voltage is fixed. So if you're giving the 5 volt, the same amount of uh, it is also going to be current will be flow. So it is going to be fixed. We can't able to change it. So it is going to be calculating for zeroth second. What is that voltage value? What if for the 0.1 second? What is the voltage value? 0.2, what is the voltage? So if you just check this value, there is no changes in the signal or voltage or current, right? So it is keep on maintaining the same voltage. At this time, there is no frequency is going to be produced. For per second, there is no changes in the signal or current. Okay, how we can able to identify the frequency? There is no frequency is going to be provided. Okay, so that's what it is having less loss. So when you're going to be compare this frequency, when you're going to be compare the DC circuit, it is having a less loss of, there is no frequency is going to be acquired. So you might be see some of the frequencies, some of the voltage fluctuations or just changing some ideal values at the time. Minimal amount of frequency going to be provided. It is going to be unpredictable value. Okay, and then we are going to study about the alternative current. So till now we just give you have some clarity about the DC current. DC current just required the potential difference between the two end of the node, it will be started to creating the charges. That is the DC current. DC current can able to store in devices easily. So it is going to be the fixed value. Voltage is not going to be changing with respect to time. So for this reason, it is not having any frequency. So there is no losses going to be happens. So same time, who inverted this DC current? Okay, so we know that Thomas Edison. So and DC current was very popular. So on that time, okay. So on that time, so everything was trying to be built in this DC current. So for at the same time, they started to inverted this alternative current also. So we know that who wanted this alternative current, so Nikola Tesla. But why they didn't allow to this alternative current? So that is having some of the disadvantages, but more advantages which is present in this alternative current. AC was invented by Nikola Tesla. Yes, we know that one, right? So why they didn't, he didn't allow to bring up this AC. So some of the demerits is there, but AC was get very popular. So later on, he just invented the AC power plant. So what is the biggest advantages in this AC alternative current? So we can able to transmit it to the long distance. So, so DC, it is in the short distance, we can able to use it that. So now we can able to use this DC current in overall area, but you have to change it complete entire things. Okay. So at the time, AC was played a big change. Okay, the big change which was came from this is alternative current. Now, some of the disadvantages is it is going to be changing continuously with respect to time. We will see that what are those. Okay, and why they hesitate to bring up this alternative current. Okay, so we will see this concept. Okay, but later on they have been discussed, they have been inverted the complete AC power plant. So it was eating very popular. Okay, so now we'll discuss about the alternative current. Okay, so alternative current, we know that this. name itself is just having that alternative current, continue alternating. Okay. So before that, where it is actually going to be used and when up to it is actually going to be used. So from your electricity board to your home, we can using this alternative current. So yeah, current is coming from your transformer. So through that transformer, for every ohm, it's just getting a separate current. So electrical board. So if you are having you're just staying in your flat or anywhere, so you can able to see that electrical board. So from the electrical board to your home, we will get this AC. Okay, so alternative current. So you can simply see this one, how it is big. Okay, your transformer will be in your 3 to 5 kilometer distance. Okay, can you do this on a DC current? All right. So that's what the alternative current will be too. Okay, it will be moves in the long direction. It will be travel through this long direction, long distance. Okay. So this time, so this is your transformer to your electrical board. Okay. And this is your home. Okay. It will be come through this direction through up to this distance. Okay. So we are going to be consider this distance at all. This is very important parameter. Okay. And now AC is sinusoidal waves are going to be creating the rotating coil with a magnetic. So this concept is how this alternative current is actually producing. So we already know that how the DC current is producing. So positive, when you're going to be giving the positive and negative charges, so potential difference is going to be creating the electrons will start to create, the current is going to be flow. So this is a normal DC current will be 2, but how the alternative current is going to be changing? Because this alternative current, if you just check out this alternative current, we already discussed this concept. Okay, because you just consider this is your form of AC and DC. This is your DC and this is your AC. So what about this DC? DC is not going to be changed with respect to time. If you are taking a voltage or current, it's not going to be changing with respect to time. But AC is not. AC is completely changing. It's it is going to be travel in both direction, positive and negative. Alternatively, it is going to be changing for each and every time the values get changing here. That is the AC current. Okay. How it is actually going to be generated. So how the AC is actually going to be generated. So that's what we are going to be discussing here. For example, we just take this fun. Okay. This is how the AC is going to be created. Okay. So for example, you just take a example of this one. So you just this is how this AC is going to be created. First point is imagine a coil of wire is just rotating inside the magnetic field. So you're just having a magnetic field which is producing magnetic field. Two magnet is there. One is called as a north and another one is called as a south pole. Okay, just having a two magnets and in between you are having a coil. Okay, this is how the AC alternative current is going to be created. Okay, so magnetic field you are having, and imagine a coil of wire wounded. Okay, so in between you are having a coil which is having a wire wounded coil you are having. Okay, so wire wounded coil you are just having inside that. Okay, and here next thing we are going to be if you are going to check it out here. As a coil rotates, an angle between the coil and magnetic field changes. The magnetic flux is going to be created. The thing is, so this is your coil. That means this is your complete coil, which is having wire wounded thing. Okay. So whenever it just we have to just keep closer this magnetic field at the time, the wire depends on this coil wire. It is started to rotating. Okay. Whenever it just bring it together, so the coil will be started to moving. So whenever we just having same polarity, it just ripple each other. Okay. So whenever it just started to attracting the same polarity, it will be started to attract each other. So this concept we know that, right? So through this, it will be started to creating the current. Okay, we will tell it as in first of all, it will be started to creating the magnetic flux. So what it actually going to be creating, the magnetic flux is going to be creating. So whenever both as get interrupt each other. Okay, so you can able to see that. So whenever it rippling each other, so at the time, so it will be started to creating one of the magnetic flux. So the changes in magnetic flux. So that magnetic flux which induce the sinusoidal voltage. Okay, so through that it we started to creating the current. Okay, the magnetic flux through that they started creating the current. So whenever you are having a two magnets, you just consider these two as your magnets, and I'm having the current carrying. That means you're having a coil which is surrounded by the wires. So whenever we just keep on moving this together very close up, so this coil will be depends on your poles if we started to move. Okay, when it started to move, it will be creating the magnetic flux. The flux is going to be started to create. So depends on this magnetic flux, that flux is actually get changing, right? Because first time the flux is going to be started to create like this. And it is moving toward like this. So sometimes it will started to create like this. Okay. And the flux changes. Whenever the changes in the flux, it will be started creating the voltage. That means it will started to creating the current. Okay. At the time, the sinusoidal waves is going to be created because the flux is actually changing. Okay. So that flux, actually, the continuous changes in your flux, which is creating the sinusoidal waves. The voltage is actually get changing with respect to time because it is continuously get changed. Depends on the flux is actually going to be created. Okay. Since the rotation is continuous, first of all, if it is hitting both are in the different one, so it will be creating one rotation. Okay, when it is started to hitting this region, it will be started to create this rotation, clockwise, anti-clockwise, clockwise, anti-clockwise, so creating the flux towards like this and this, like this. So it will be creating a some different alternative voltage. Okay, so first is positive and then is negative. So this is how it is actually going to be created. If it is creating the first voltage, okay, the first voltage has been created like this way. Okay, one will be started to move this direction, clockwise direction, and the second, when it is it towards like this, it towards, I mean, it will be started to move towards this anti-clockwise direction. So it will be started to create a wave like this. So again, it will be started to create a wave like this. So why we need to represent this form? Because this sinusoidal wave, because that voltage is continuously get changing. Okay, so we can also represent in the square ways or different waveform. Okay. So here we can easily calculating with the help of the sine operation. So we are just using the sinusoidal wave here. Okay. And in this scenario, the connecting the coil to the load through the slip rings allows the AC current to deliver the external circuit. Okay. So through this is called as an okay, so finally, we are going to be acquire the alternative current because through this magnet and through this coil, you're just actually producing some current that is called as an alternative current. Okay, so that alternative current, it is now going to be started to producing the final output. That output you can able to give through this the conducting the coil through the load and through the slip ring which allows the alternative current to be delivered to an external circuit. So if you want to be give any external circuit, so it will be actually going to be get produced. Okay, the alternative current will be so it comes towards this direction. Okay, and why we are going to be considering the frequency of this AC. Okay, so you will got some clear about this point. So magnetic poles, which is going to be helps to moving the coil. That movement of the coil, this is called as a magnetic field, right? At the time the coil get moved, the movement of coil, which are actually producing the magnetic flux, the depends on keep on changing the magnetic flux. It is producing the current. That current is not a normal current. That current is called as an alternative current. We finally acquire this alternative current. How the alternative current will be looks like? The alternative current will be looks like this sinusoidal wave. Okay, because first time it just positive and negative. Just keep on changing the voltage. So this is how you're going to be acquiring the value. That's all cool. Okay, and what about the frequency we are going to be calculating? I already explained that in DC circuit, the DC, there is no frequency set because the voltage is constant. With respect to time, the voltage is fixed and constant. It is not going to be changing, right? But when you consider this AC circuit, with respect to time, your frequencies get changed. That means your voltages get changed. Okay, for zero point 0.1 second, somewhat you can able to acquire the zero point 0.1 amount of frequency value. That means in hertz. Okay. So in next, you will get somewhat for zero point 0.2, you will get somewhat different voltage. You're going to be calculating in form of voltage. So voltages keep on changing. You're going to be calculating the frequency value also. Okay. So that is the thing. Here it has been mentioned, guys. Number of complete cycle per second is called as in frequency. Okay. How you're going to be calculating the frequency? So whenever your voltage is keep on changing with respect to time, you're going to be consider the frequency value. But what actually frequency you're going to be calculating? Your frequency, how many number of cycles. So you just consider this is your cycle. Okay. So for per second, okay, for per second, you just acquire the 3 cycle means that is your one frequency value. Okay. For next second, you will get 2 cycle means that is your frequency. So for per second, how many number of frequency cycle you are just getting? That means how many number of cycle. Okay, that is going to be considered as a frequency. Okay, in many countries, 15 hertz. Okay, that is going to be calculating with respect to how much it has been changed per second. Okay, and in US and other countries, it is going to be using 60 hertz. For our India, it just required a 50 hertz. Okay, and what are the source which is helps to creating that? So alternative current and voltage not be stored in any batteries or cells. Yeah, we know that it is one of the thing not going to be for store. It just generate alternative current is actually going to be generating by the magnet and coil and so these are the components which are going to be generated only, not going to be get stored. Okay, and it is much easier to be generated. So if you are just having this component, we can be able to create it. How much amount of quantity you want to create it, we can easily going to be created. Okay, an alternative current voltage source is on the other hand. So how where it actually going to be used? We know that most of the electrical appliances we have been using bulb and some of the fan mixer. So these are the stuffs which requires the AC current. So you're already going to be also you're going to be think about this concept easy to understand. What are the components in your home which requires the DC and what are the components which is going to be using AC? Okay, so in this concept, DC means okay, that is a direct current. If you are just giving the 5 volt, it will be works. Okay, if you want to be not giving this exact 5 volt, it is going to be the power is get off. The alternative current is not be like that. So it is you can able to it is going to be continuously get changing. Okay, the voltage is continuously the current is continuously get changed. Those two examples. So for example, you just take your TV, charger and these are the example for DC. And fan your mixer, so you just take it live. These are your alternative current. Okay. And in this scenario, what it actually going to be happens? So for this DC components, your EV or adapter, okay, and this is your fan, and this is your light, and this is your mixer. These are the components which just can able to see the difference. Okay, so if you are just getting very low voltage in your home, okay, it will be completely get turned off, right? So it is just require the fixed amount of some voltage, but you can able to check it on this alternative current. You can the variation, the low voltage, you can able to feel it on here. Okay, so that is the thing. So this is not kind of exactly having a low voltage at all. So whenever it just having producing the some volt difference in the voltage when you're going to be providing the less voltage, so that is called as a low voltage. You can able to feel it on the appliances. When you're going to be giving the high voltage, it's just producing the high amount of current. You can also feel it on the electrical appliances, right? So but it's not like that. So when you're going to be not given the exact value, it is going to be get turned. Okay, and the next important thing is characteristics. Okay, first of all, you complete the characteristics. Voltage is alternative one in AC current. So alternative means it is going to be keep on changing positive, negative, positive, negative. Your frequency is typically about this value. Okay, if you want to be can be transmitted over the long distance. So that's what the AC is going to be most probably get used because it can able to carry over this long distance. The alternative current will be in the long distance. Okay, and you can easily step up and step down the transformer. If you want to be give the high amount of voltage, yes, if you just give the step up the step up. If you can do the step up the voltage. If you want to give the low amount of voltage, you just do the step down. Okay. So that's what you can able to feel it. Depends on the appliance. You can able to step up and step down the voltage in the value. And the types of waveform it is having. So most of the thing for AC waveform, you are going to be using the sinusoidal waveform. Okay. And what are the key terms in AC is? And these are the key terms. Okay. So if you're going to be study about the alternative current, so these are the terms you might be studied out. Okay. What are the first term is? It is called as a peak value. Okay. What is mean by peak value? Okay, what is mean by peak value? So we will discuss that. Okay. So maximum value of the waveform. For example, you already given that, you already know that uh, we are just in your home, you just get only the 230 volt. Alternative current is 230 volt. Okay, AC which is come through your home is 230 volt. But in this concept, in some cases, if just accidentally provide some 330 volt, what will be happens? Your electrical appliance is not going to be get work. Okay, so this value is called as a peak value. Okay, so for example, you already know that it just work, it just always producing the 230 volt. Okay, some ups and downs will be happens, but some scenario if it is producing that 330 volt, that is considered as a peak value. Okay, you might be you might be went through this speech and also we always check it out which wave is having a more height. Okay, so that is having the high peak value, right? So that's how if you are having a 230 volt, sometimes if it is producing some highest point, that is going to be considered as an highest point. That is called as considered as a peak value. We are going to be considered as a peak value, for example. Okay, and what is mean by RMS? That means root mean square is equal to the DC effect. That means equivalent DC voltage that producing the same heating effect in resistance. Okay, you already know that it is going to be providing in sometimes it is going to be providing some peak value. Okay, so we already know that the voltage alternative current voltage it is going to be provided up to the 230 volt. If in case it is providing the peak value of 330, we are going to be reduced up to the 230 volt. Okay, what we can able to do that at the time we are going to be introducing this root mean square value. Okay, what the value has been came here, you are going to be divided with the root 2. Okay, you will get the value of 230 volt. Okay, how it is actually going to be applied in this voltage? Okay, it is going to be producing some same heating effect. Okay, it is going to be try to maintain the value of alternative current. Okay, so it is going to be trying to maintain the wave. Okay, it is trying to maintain this value. So that's what we are going to be introducing this root mean square value. Okay, so whenever you are getting this kind of peak voltage, it helps to reducing this value of 230 volts. So for that, we are going to be using this root mean square value. So it is going to be helps to checking with the mathematical formula. Okay, in the sine wave, so we are going to be using the peak value divided by the root mean square value. And what is frequency? So how many number of cycles? Okay, so if you are going to be taking the uh, alternative current, this is your alternative current, and how many number of cycles which is going to be passed per second. That is called as a frequency. And what is mean by phase? Because these are the terms which is going to be used in the alternative current. So that's what I'm just telling you that. So you just keep it on the mind. Okay. And timing difference between the voltage and current. Okay. For example, you're going to be calculating with respect to voltage and time. Okay, whether both are having the same phase or not. Okay, so if you are facing any difference in your voltage and current, so that is going to be calculated. How much phase difference between your voltage and current. So that is called as an phase. Okay, so this is the thing about this AC and DC current, guys. I hope you got clear idea about this. What is AC and what is DC? So if you have got clear about this video, so if you got learned something new about this video, so in this comment section, so you just post like as I learned new. Okay, so if you are feeling good about this video, so you just post it on the chat box. I need more videos like this. Okay, so thank you guys and thank you for watching this video. I hope you really enjoyed this video and we are going to be meet you on this next video. Until it's goodbye from Charlotte. Bye guys.